Hey y'all, so I'm a self-confessed PLC geek, and I like to come up with things to do with PLCs that usually have no real purpose. They're just kind of fun to build, and actually building it is most of what I enjoy doing. And this is one of my creations that I just actually brought back to life. A few years ago I stumbled across these AC motors. I got a couple of them. 120 volt reversible, nothing fancy about them, nice and small. And I just started figuring out what I could do with it. And this is the result over a lot of humming and hawing and trying this and trying that. So effectively what's happening is I have a PLC that is communicating, and I'm using some wireless I.O. devices, and I'll explain those in a second. But I'm using the I.O. to control the drive. I am also reading information from I call it a linear drive device itself. I've got a potentiometer here, which is providing an analog signal coming into the analog remote device. I've got a set of switches on either side. The top switches are position switches that are being read by the PLC. The bottom switches are fail-safe switches. They're actually tied directly to the drive, so if the device goes too far to one end or the other, it'll stop and it won't overrun. Those turned out to be, when I originally first built this, an afterthought after tearing one end off it, because this is actually a pretty strong little motor. So the I.O. devices are actually, I've got what we call a protocol master on this end and a I.O. remote. The master is pulling the remote independently of any communications to the PLC, and you can see the activity on the LEDs. It is continuously reading and writing to the status of the inputs and outputs. I've got 8 discrete inputs, 8 discrete outputs, 4 analog in and outputs. The PLC is reading and writing message instructions to some registry tables in here, and kind of the cool thing with this particular product is there's only 2 message instructions going back and forth. One is reading all of the inputs, and one is writing to all of the outputs. And again, as I'd mentioned, the outputs are going to the drive to start, stop, and direction, as well as an analog output to feed the speed. And then inputs are coming from the switches and the rheostat on here, and of course the drive is controlling the motor. The other thing that is attached to the drive is I've got a joystick that is also providing an analog input, and I can use that to control the device itself. So a couple of modes. One is just one direction or another, and I've got a couple of switches tied to the PLC up here. There's the other direction. And then the other mode is automatic, and it'll just sit there and cycle back and forth. And you notice it goes to a certain spot, slows down, and then once this hits the switch, it reverses it, and it gets to a certain point, slows down. I've got some speed zones in there so that if it's running at full speed, by the time it gets to the switch, there's enough momentum to carry it, and it goes too far. So that's why it slows it down. And then lastly, the other mode is with the joystick. And you'll see with the joystick here, and if I move the joystick one direction, the drive will go that direction. Still has the same slowdown feature, and when it hits the switch it stops. Then I have to use the joystick to go the other direction. You'll notice the joystick is also proportional. So I can control it slow, control it fast, stop and go. And when it does get into these slowdown zones, I still have proportional control, but I can only go so fast. So that is my useless project for today anyway. Thought you might enjoy it. Again, I know most of you that are looking at this are PLC geeks. Otherwise, I don't think you'd be watching this. And hopefully, like me, you like coming up with cool things to do with PLCs and drives, and hope you'd enjoyed it.